Okay, welcome everybody. So today we're going to talk about isomers and also functional groups. And so when we talk about isomers, you need to understand the following ideas. You need to be able to describe what a structural isomer is, and you need to be able to name these isomers for non-cyclic alkanes. So that goes up to 6 carbons. They want you to know up to hexane. And then you need to be able to name and draw the straight chain alkenes as well. So we'll talk about how to do that, and we'll talk about what an isomer is when we do this part of the chapter. So when we define an isomer, we say that it's a compound that has the same exact molecular formula, so it has the same number of atoms in it, but they're arranged differently. They have a different structural isomer. And so what they're showing you here is a combination of 4 carbons, 8 hydrogens, and 1 oxygen that are combined together into 20 different isomers. And so all of these have that same molecular structure of C4H8O, but what we see is that they could have a different structural arrangement. And so what makes this interesting is that these isomers all have different properties. They have different polarity, different reactivities. Something over here where you have this 3-membered ring, number 20 and number 19 in particular, are really reactive. And that's because of the strain in that carbon ring in the bonds there. It makes it really, really reactive. And so all of these have different types of reactivity, different types of properties, but they have the same formula. And you should kind of remember this from last year. Now, you're not going to be asked to draw 20 isomers for a compound. This is just showing you, the vast range of isomers that could occur for something that has 13 atoms in it. And that's pretty impressive. Now, if you take a college organic chemistry class, you will do something called stereoisomers or optical isomers. And this becomes really important when we're dealing with things like amino acids that have 2 optical isomers called L and D, or S and R as it's called in organic chemistry. And those isomers, they actually have different activity in the body, especially when it comes to amino acids. You can ask your AP Bio teacher about the different stereoisomers for amino acids and how it makes them either recognized in the body or how it makes them not recognized in the body. Okay, so here for example we have our alkanes. We're going to deal with the non-cyclic ones. We're not going to get into the ones that have where they're arranged in a ring. And so let's see what we can do here. Can we draw all of the isomers for the first 6 carbon atoms? Just hold on one second. So go ahead and give this a try. Try and draw all the structural isomers that you can for any of the alkenes up to 6. So for example, you could draw methane, CH4 like this. You could draw ethane, C2H6 like this. You could even draw ethane in the skeletal form where you draw it just with a line showing the 2 carbons. Or you could show it condensed where you draw it like CH3, CH3 like this. So try that for up to 6, see how many you can get. Pause the video and try that out. So hopefully you got a bunch of them, and in fact if you were to draw them all there would be 13 of them in total, and they would look like this. So here's showing you methane, ethane, propane, butane, methylpropane, and then we have pentane, and then we have methylbutane, then we have dimethylpropane, hexane, we have 2-methylpentane, 3-methylpentane, 2,3-dimethylbutane, and then 2,2-dimethylbutane as well. So here are 13 of them. all of them have the same general formula with their isomers. And so, for example, what you can see here is that the first 3 chained carbon alkanes, methane, ethane, and propane, they don't have any isomers. But when we get to the 4-membered, so we start with butane, this has 2 isomers. And then pentane, it has a total of 3 isomers. And then hexane has 5 isomers. So the idea is to rearrange the atoms in order to get a different structure that has a different name and different properties. So here's showing them skeletally. Now, notice I went through and I actually named them for you. These were all the alkanes. Notice I ended them all in ane. You might remember this from last year. And then the number of carbons, they tell you what the prefix is, and you should know up to 6: meth, eth, prop, bute, pent, and hex. If you want a fun way to remember how to get up to hex, I can tell you that one of my students from last year came up with a pretty funny way of remembering that if you don't remember them or if you have difficulty with that. So what I'd like you to do is, go back to that slide again, and I went quickly through it, but go back and try and name those isomers, at least the straight chain ones, the ones that are not branched. You have to know how to do branch carbons as well, and so these are the rules for naming branch carbons on the left here. So you start by finding the longest chain. And you usually circle that longest chain. So I can give you an example over here. I would look at the longest chain and I would circle it. And I would name that longest chain. That longest chain would be propane. So that would be propane. And then I would see hanging off of the propane that there's a methyl group on the second carbon. I would call it 2-methylpropane. Now really, I don't use that 2. That was part of the slide presentation. I don't use that 2. Anybody know kind of why I wouldn't do that? Maybe we can discuss that in class, why I wouldn't go ahead and do that. But notice there's 1 carbon hanging off of here. That's where the methyl comes from. If it was 2 carbons, it would be ethyl, and 3 would be propyl, and you can have 4 carbons or 5, and that would be butyl or pentyl, but they don't usually do that. So you need to number where the carbon is sort of hanging off of the main chain, and you number that carbon when there is more than one choice. You always want to give that number the lowest possible number that you can. So if it could be on a 2 or on a 3, you want to number that chain so that it's going by the lowest number of carbons total. So if you have 2 of the same branches, you call them di. So you would do like dimethyl, diethyl. 3 branches would be tri, 4 branches would be tetra. So you could go back to that slide on the previous couple of pages here and name some of these, and we can do one of them. I went through it quickly before, but if I look at something like this one, number 13, I would circle or highlight the longest chain of carbons, and so that would be 4 carbons, so that would be bute. It's all single bonds, so it's butane. And then I need to number the 2 carbon groups coming off of it. What I notice is that these 2 carbon groups coming off of it are the same exact chain. And so they're going to get now di, and since they're both 1 carbon, they're dimethyl. Now because those carbons are on or can have more than one possibility, we see isomer number 12 here, the methyls are on different groups. I need to number where they are. And so I can number them going from left to right if I wanted to. I could go from left to right and I would number them 1, 2, 3, 4. Or I could number them the other way. I could number them from right to left, 1, 2, 3, 4. Because the lowest combination is numbering from right to left, this becomes 2, 2. And a question I get a lot is, well, why can't you just do like 2-dimethyl? Why does that have to be 2, 2? And well, you need to tell where both the methyls are. Even if they're on the same carbon, you have to do 2, 2-dimethyl. So we did naming straight chains, naming branch chains. We're going to practice this in class quite a bit. But you also need to know how to name alkenes. So alkenes have that double bond. They have that series CnH2n, so CnH2n in a general formula. They end with the suffix -ene. And so, like you should be able to draw the first 6 straight chained alkenes and name them. And you could do some of the branch ones as well. So you need to also put where the position of the double bond is, but you only do this when you're starting with bute. You don't do F, so there's no ethene or F1ene or prop1ene, because it will always be on the first carbon. Notice the IB also does it a little bit different than you're used to. If you remember back from last year, you would say like 2-butene. Notice here they put bute and then 2 and then ene. So they actually put the number right before the ene suffix. A little bit annoying, but that's how they do it. So here they are. If you want to take a minute, you could try them on your own. And so here they are, the first 9 and all their positions. And this is, ethene, propene, 1-butene, 2-butene, 1-pentene, 2-pentene, 1-hexene, 2-hexene, 3-hexene, or as they do it in IB land, starting with bute, this would be bute-2-ene. This would be number 3 here, bute-1-ene, bute-2-ene, pent-1-ene, pent-2-ene, hex-1-ene, hex-2-ene, hex-3-ene. Notice I don't do a hex-4-ene. Maybe we could talk about why that's the case in class. Alright, so I'm going to stop the video here. I wanted to talk to you about functional groups, but I'm going to do that next time. Here's a summary of what you need to know for this. Now, we will also do these functional groups that are in Lesson 3 next time. And in Lesson 3 for this, you might want to get a head start on this. You should know all of these different classes. And if you haven't done so from last year, you should memorize this chart. There's some new ones on here, but generally it's the same as what you had last year. They want you to know the name of the functional group and also the ending, and then how to do some naming. We'll practice that in class as well. Alright, thanks for watching. I hope you're having a good break. Talk to you soon.